A simple pendulum consists of a bob of mass 1.8 kilograms attached to a string of length 2.3 meters. The pendulum is held at an angle of 30 degrees from the vertical by a light horizontal string attached to a wall as shown above. On the figure below, draw a free body diagram showing and labeling the forces on the bob in the position shown above. Calculate the tension in the horizontal string. The horizontal string is now cut close to the bob and the pendulum swings down. Calculate the speed of the bob at its lowest position. How long will it take the bob to reach the lowest position for the first time? This problem is a multiple concept question. Let us do the problem here. The pendulum bob is attached to two strings. One is attached to the vertical support and another one horizontal support. We have to find out the tension in the horizontal string. That is the first bit. And then the another one is we have to calculate the speed of the bob at the lowest point. This is the lowest point. Here we have to calculate the speed of the bob and then how much time it takes for the bob to reach the lowest point for the first time. Okay, so before going into the mathematical things, we will have to draw the free body diagram of the bob in this position. So, what are the forces acting on the bob? One is the weight acting downwards. Another one is the tension in the vertical direction. That means at an angle of 30 degrees. Another one is the tension along the horizontal direction. So this I have drawn. So the tension is in this direction. Arrow mark represents no. And then horizontal tension is like this, and then weight is downwards. Next, what I did is I resolved this tension into components. One is vertical component, another one is horizontal component. Here you see this one. This is the forces after resolving the tension into components. Okay, here the angle is given as 30 degrees, and then as this angle is 30 degrees, this angle is again 30 degrees because they are alternate angles. Okay. Next, we have to find out the tension in the horizontal string. See here, ftx is equal to fth. Am I right? Both are the horizontal components. They balance each other. So ftx is equal to fth. What is ftx? ftx is equal to ft sine theta because this is opposite to the angle. That is why this is ftx is equal to ft sine theta. Okay. Here theta is equal to 30 degrees. Therefore, ftx is equal to ft sine 30. Okay. So here we have to find out ft. If we know the ft, then we can find out fth. Ftx is equal to fth. Therefore, the answer we will get. So to find out tension in the string, we have to use the vertical components. So fty, the upward direction, mg is downward direction. Therefore, fty is equal to mg, or fty sigma fy is equal to force equation. If we write sigma fy is equal to fty minus mg is equal to 0, or fty is equal to mg. We know mg because mass of the bob is given as 1.8 kilograms. Okay, so fg is equal to 1.8 times 9.8. That's mg. Therefore, mg is equal to 17.64 newtons. Okay. So ft cos theta is equal to, because this is the adjacent side to the angle, therefore it is cos component. Therefore, ft cos 30 is equal to mg, or 17.64 newtons. Therefore, ft is equal to 17.64 divided by cos 30 gives 20.37 newtons. Now, to find out fth, we go to the x component forces. Therefore, ftx is equal to sigma ftx is equal to fth minus ftx is equal to 0. So this is right side and this is left side, and right side is taken as positive, left side is taken as a negative. Therefore, fth minus ftx is equal to 0, or ftx is equal to ft sine 30, or fth is equal to 10.18 newtons. Okay. Ft we already found out, and then substituting that value here, and then sine 30 is equal to half, we get the answer. Okay. That is one thing. Next thing is we have to find out the velocity at the lowest point. For that, what we do is we will calculate the, we will take the energy component into consideration. We know the total energy of the system is constant. Therefore, the bob has the gravitational potential energy at this point, and then it has the kinetic energy at this point. Therefore, entire gravitational potential energy becomes kinetic energy by the time it reaches here. Okay. At this point, it has only gravitational potential energy. The moment the string cut at this position, then the pendulum starts vibrating. And then the moment the pendulum starts coming down, the gravitational potential energy gets converted into kinetic energy. Now, we know gravitational potential energy is equal to mgh. Here, ug is equal to k. So, mgh is equal to half mv square. Rv is equal to root 2 gh. We know g value, but we don't know the h value. So, we have to find out h value. How to find out h? Using the geometry of the figure. So, this is the figure. And then this is the height. Am I right? This is the reference point. From the reference point, the bob moved this much of height. Okay. So this is the height. Now again, this is a right angle triangle, and then this is the length L, and then this is the total length of the pendulum is L. And then only this part we have to know. So L minus H, this part is L minus H. When we consider the right angle triangle, this part will become L minus H. Therefore, cos theta is equal to adjacent side by hypotenuse. Therefore, cos theta is equal to L minus H by L, or L cos theta is equal to L minus H, or H is equal to L into 1 minus cos theta. We know the value of L. It is given in the problem as 2.3. Therefore, H is equal to 0.3081 meters. Plugging that value in the equation V is equal to square root of 2gh, we get V is equal to 2.5 meters per second. Next, we have to find out the time taken by the bob to reach the lowest point for the first time. See here, the bob has to travel here and then go to other end. For example, if you take this one, this is the bob, okay, pendulum. So here, this is the initial position, because here is the string joined to the support. The moment the string cuts, the pendulum comes to this position, and then this is the equilibrium position. From equilibrium position, it goes to other end. Okay, 1 second. It goes to other end. So from here, it goes to this position, and then from this position, it comes back to this position. And then from here, it goes to this position. The entire, so 4 parts, 1, 2, 3, 4. All the 4 parts is equal to, that is the one oscillation. And the entire journey is called one oscillation. Starting point to end point, and again coming back to the starting point is called one oscillation. And this one oscillation, time taken to complete one full oscillation is equal to time period. Okay. So, one oscillation, time to complete, right here. Time to complete one oscillation is equal to time period. Time period T. So T is equal to 2 pi root L by G. And then he is asking us to find out the time to reach the bob at the lowest point for the first time. So this is 1/4 of the journey. Am I right? 1, 2, 3, 4. So 4 parts is equal to T. So 1/4 of the T. Therefore, first we will find out the T value. And then if we divide that value with the 4, we will get the answer. Okay. So T is equal to 2 pi root L by G for the simple pendulum. Therefore, T is equal to 2 pi root L means L value we know 2.3, G value 9.8. Therefore, T is equal to 3 seconds. And then 1/4 of 3 is equal to approximately 0.75, or here exact value 0.76 seconds, or 0.8 seconds is the answer for this question. Hope this helps. Thank you. Bye bye.